week one is all about getting a foundation, kind of the fundamentals out of the way, and starting to build on a base. So the whole point of the readings, chapter 1 and chapter 2, and what you're going to be learning this week, is to build that foundation and to basically catapult from here. So let's talk about some of the concepts that are going to be covered. One of the concepts discussed in chapter 1 is the composition and how we describe the atmosphere. There are several ways to actually describe the atmosphere. You can describe it through density, you can describe it through chemical makeup, composition, or you can describe it through temperature. One of the ways is the types of molecules that you'll find. The heterosphere is well mixed, closer to the Earth's surface, so all the molecules, nitrogen, oxygen, all your main components of the atmosphere are well mixed. The higher up you go, those molecules get displaced and filtered out by weight. So it's called a homosphere, the higher up you go. There's also ways of talking about electrodynamics that occur in the atmosphere. We're not going to worry too much about that in this class. What we are going to focus on, as far as how the atmosphere is layered, is based on temperature. And keep in mind that the lowest layer of the atmosphere, as defined by temperature, is the troposphere. And that is where almost all, 99%, I would say, of all the weather occurs, is in that troposphere, that bottommost layer. Another concept that's introduced in chapter 1 of your book is the greenhouse effect. You'll see this talked about again in chapter 2, but this is a very important concept to understand for the whole scheme of weather. You're not going to have to keep this in mind necessarily for each individual thunderstorm you study, but it's very important to understand that the greenhouse effect is absolutely necessary. It is a good thing. I don't know, I can't tell everyone's background, what you may have heard, but the greenhouse effect is actually very good. If we didn't have the greenhouse effect, that is the components of the atmosphere, those greenhouse gases in the atmosphere, if those didn't exist and they weren't helping to insulate and helping to keep the Earth's energy back towards the ground and keeping us warm, we would actually boil during the day and freeze at night, just because the atmosphere helps to shield from the sun, and most importantly, helps to insulate the energy coming from Earth from escaping back into space. So understand the greenhouse effect is very, very important for life on Earth, and is really what makes life existence possible. The last thing I want to say about chapter 1 is just a mention of phase changes. When we talk about water changing from a solid to a liquid to a gas, those are called phase changes. Those are extremely important to everything we are going to talk about in future topics of this class. So it's important to understand those. Evaporation, and the opposite, of course, is condensation. Then we've got melting and freezing, and two other ones that maybe you're not as familiar with are sublimation and deposition. The most important of those is going to be evaporation and condensation. Why, in general, why are any of these phase changes really important? It's the concept of latent heat. It's mentioned very briefly in chapter 1. It'll be mentioned again in chapter 2. You can bet it's going to be mentioned in almost every other chapter of the book. Latent heat is energy that is either stored or released because water is changing phase. It's changing from a solid to a gas, or from a gas to a solid. We'll talk more about that in chapter 2, but make sure to focus on that in your reading, and make sure you kind of get start focusing on that and understanding that. And that's going to be really, really important as we go along in the class.